Recursion in C++. A recursive function is one that calls itself to solve a problem. A recursive function knows how to solve the simplest cases of a problem, also known as the base cases. It then calls itself again to solve more complex cases recursively based on the simple cases. There's a caveat though. The function cannot keep calling itself indefinitely and must have a termination condition. Otherwise, a runtime error will be generated, which is known as stack overflow. Whenever a function calls another function, this is known as the call stack. Function A calls function B calls function C. This is known as the call stack. In the case of recursion, it's going to be the same function. So function A calls function A again, calls function A again and again and again. However, the stack memory has a size limit. And so there's a check by the operating system and the compiler where if you keep calling the same function and you exceed the maximum allowed function call depth, it will then throw a runtime error known as stack overflow. Okay, to understand recursion, we must try out an example. I'm going to show you the factorial function example. If you don't know what a factorial function is, simply in math, n factorial is actually n multiplied by n minus 1. In its nature, it's a recursive function here, because in order to calculate the factorial for n, you first have to calculate the factorial for n minus 1. And we know that the factorial of 1 is 1. And the factorial of 2 is going to be 2 times the factorial of 1, which is 2. The factorial of 3 is going to be 3 times the factorial of 2, which is 2 times 3 equals 6. Why would you even want to use recursion or learn recursion? Any problem that can be solved recursively can also be solved iteratively without recursion. However, a recursive function is normally chosen when the recursive approach more naturally mirrors the problem. What does that mean? That usually means in order to write the same code in an iterative fashion, the program is going to be so much complicated. There's going to be a lot more code. Some problems might require you to write pages and pages of code to implement iteratively. However, if you try the recursive approach, it might actually be no more than like 4 or 5 lines of code. So that's why recursion is very useful in certain situations. But always remember that recursion has performance impact and only resort to it when you need it. The overhead of recursion is what makes it not so appealing. Recursion is going to be expensive in terms of memory as well as CPU time. Sometimes it's easier to implement the function iteratively and try to optimize it, whereas in the case of recursion, it's not going to be as easy to optimize and fine-tune the code. And the memory impact is that each time you call the function again and again, all the variables that are local to the function, in addition to the parameters of the function, are going to be copied on the stack. Even though your computer might have a large memory, the problem here is that the stack memory is limited in size. Typically, the stack is much smaller than the heap, and if you try to put everything on the stack, then you will get the stack overflow problem. So the takeaway from this is that you should avoid recursion in performance situations because recursive calls take time and consume additional memory. Alright, let's jump into Visual Studio to see how we can implement Factorial both in an iterative fashion and then as a recursive function. Okay, so here I am in Visual Studio. Let's go ahead and create a project. File, New Project. From the New Project window, make sure you have Visual C++ template selected. Click on Win32, and then from here select Win32 console application. And let's call this one Factorial, because we want to implement the Factorial function. Click OK. On this page, click Next. And here, make sure you have Empty Project selected, then click Finish. Alright, let's go ahead and create our main.c. Right-click on Source Files, Add New Item. And let's call it main.c. Then click Add. Okay, so in this lecture, we want to learn how to implement the factorial function in 2 ways. The first one, we're going to do it iteratively, and the second one, we want to see how to do it recursively. I'm going to create an integer factorial function, which we give it an integer n, and then it should return to us the factorial for the number n. Here are some examples. If n equals 0, n factorial should be 1. And then if n is 1, the n factorial is going to be 1. If n is 2, n factorial equals factorial of 1 times 2. And the same goes for n equals 3 or 4 or 5, etc. But the formula is as following. N factorial equals n times factorial of n minus 1 as long as n is greater than or equal to 1. So, okay, so how do we translate this into code? Let's say we want to save the value here. The value we want to return is going to be saved inside factorial variable. This is what we want to return. Return this to the caller. We want to go from 1 to n or n to 1 and multiply factorial by that number and save it inside this value. So there's two ways we can do it. We can either loop from 1 to n or from n to 1. Let's do this. Let's say integer I equals n. I is greater than 1 minus minus I. Now say factorial times equals I. Another way to do it is to say for integer I equals 1, I is less than or equal to n plus plus I, factorial times equals I. Because it's multiplication, it doesn't matter if we do it this way or this way. Note that I equals 1 doesn't really give us a value. We can save one iteration here, and that's what we do here. So your choice, you can pick this one or this one. I'll just leave the first one here. So this is an example of how we can implement factorial in iterative way. Let's test it out. Let's say for integer I equals 0, I is less than 10, less than or equal to 10 from 0 to 10 plus plus I. We can say printf factorial of percentage d equals percentage d. So we pass it the I and the factorial function for that value I. Okay, let's run this, Control F5 on the keyboard. Yes to build. Okay, so as you can see, the factorial for 0 is 1, factorial for 1 is 1, factorial of 2 is 2, factorial of 3 is 2 times 3, which is 6, factorial of 4 is 6 times 4, which is 24. So it keeps going all the way to the number 10 here. Okay, so that's the first implementation using a for loop. Let's leave this aside and create another function, factorial 2, or you could say factorial recursive. Okay, so how do we do this recursively? If you remember from the slides, we said we want to have the simple case, the case that is easy to solve. We can say if n is 1 or n is 0, we simply return 1 to the caller. These are simple cases. We know that for the factorial of 1, we're going to always be 1. Factorial of 0 is also 1. This is the base case, or the simple cases that we can solve. Okay, so now this is the simple case. Now, how do we do the more complex cases? We're going to return n times factorial recursive of n minus 1. So for any n greater than 1, we're going to say multiply that value by the factorial of the previous value. This is a recursive call. As you can see, this will call the function itself here. So 2 times the factorial of 1 is going to be 1. So it returns 2 times 1. If n was 3, then it would say return 3 times the factorial of 2, goes back inside, says, okay, 2 multiplied by the factorial of 1, goes back inside, it says, okay, 1, I can return 1. That goes back to the call where it was 2 times 1. Then that goes back to the call where it was 3 times the factorial of 2, which is 3 times 2. And that results in the number 6. You can see that this will work just fine for any n. However, if you use a really large number, you might run into Stack Overflow case. In our example, since we're using numbers from 0 to 10, we should be just fine. Now let's do the same thing here in both versions. I'm going to copy this here and say recursive factorial equals the second function. Okay, so now we call it one time non-recursively. The second time is going to be recursively. Instead of duplicating the lines, we can just on the same line do it this way. Run this. Okay, so the factorial and the recursive factorial should be the same values unless our implementation is not correct. All right, so that's how we implement factorial iteratively using a for loop, and then we also learned how to do the same thing using recursion. As you can see here, probably the recursive implementation is similar. The problems that lend themselves better to recursion usually tend to have much easier and cleaner implementation in recursion, and that's why we use recursion in that case. But for the most part, anything that can be done recursively can also be done iteratively like this. It's just at that point a question of trying to model the problem in a simpler way and to make it easier to understand and easier to implement, reducing the amount of code needed to actually solve the problem. That's where recursion can be useful. All right, that's it for recursion. See you in the next lecture. Periodic functions in C. Okay, today's topic is about periodic functions in C. What is meant by periodic functions? A periodic function is one that takes a variable number of arguments. In C, a periodic function can take any number of arguments, but it does not know how many arguments we pass to it. In order to know how many arguments are being passed to the function, people usually do one of two things. The first approach, which is we pass the count as one of the parameters. Usually it's the first parameter that you pass. The other approach is that you use a special value or a magic value for one of your arguments, and usually this is the last argument. So you could potentially say if it's 0, if it's null, if it's -1, that usually indicates the end of the argument list. So how do we define a periodic function? Here's an example. Void print integer count and then ... This ellipsis is what is known as the periodic function in C. Most of the functions that we've been using so far, like printf and scanf, they actually use this trick. They use this technique to allow you to pass a variable number of arguments to the function. Okay, so now how do we implement a periodic function? In order to implement a periodic function, you must include a special header file called standardargs.h, stdargs.h. This file has some macros that make it easy for you to write functions that can take advantage of this periodic list or this variable number of arguments. Typically, what you want to do is inside your function, declare a variable that points to the beginning of the list, and you do that by using this macro va_list. So you simply say va_list, mylist, or whatever name you want to give it. Okay, so before you actually start accessing the arguments of the list, you need to do one step, which is va_start. This macro initializes the list variable so it can start pointing at the list of arguments. So once you do that, you can retrieve the next argument, which is usually the first argument, by calling va_arg. You pass in your list, and this gives you back the first argument from that list. Like we discussed in the previous slide, you keep doing that until you hit one of two conditions. Either by looking at the count first. Typically, the first argument could be the count. In that case, you only loop until you get all the count elements. Or the second approach is that you don't pass in a count, you just pass the whole list, and you keep looping until you hit that special value, which is the second approach. In some cases, it could be 0, -1, or null, or some special sentinel value that you pass or you look for that terminates the list. I'll show you an example of both approaches. It's up to you to decide which one you prefer more, and you just stick to it. Okay, so back to this slide, we say va_arg, that's when we retrieve all the arguments. Once you're done retrieving all your arguments, you must call va_end. It usually cleans up any resources that were allocated as part of the whole process. Alright, so that's it for this lecture. In the next lecture, we will jump into Visual Studio so we can practice some of the stuff we learned in this lecture. Periodic functions in C. Okay, let's jump into Visual Studio. We will see how we can define a sum function that takes a variable number of arguments, and we will try to do it in techniques that I mentioned before. Okay, let's jump to Visual Studio. Okay, so here I am on Visual Studio. Let's go ahead and create a new project. Click on File, New Project. From the New Project window, make sure you have the Visual C++ 132 template selected, then click on 132 console application, and let's call this one periodic function. Click OK. On this page, we're going to click Next. On this page, make sure you have empty project selected, then hit Finish. Let's go ahead and add our main.c file. So right click on Source Files, add New Item. Make sure you select C++ file. And instead of C++, we're going to say main.c because this is a C application. Click add, and let's get started. Okay, so today we want to talk about variadic functions in C, C++. A variadic function, as we discussed before, is a function that takes a variable number of arguments. So today we want to see how we can implement the sum function that can take any number of arguments. So basically we want to implement this function integer sum that takes in any number of arguments. As we mentioned in the previous lecture, there are two ways you can implement this. So now let's implement this using the first technique. So technique number one, passing the count as the first argument. Okay, so now basically we want to define an integer count that we pass in here. Now, how do we tell the C++ compiler that this is a variadic function? So we mentioned before that we have to use that ... syntax to indicate that this is a variadic function. In order to use some of the macros that makes it easy to implement a variadic function, we need to include a file called stdarg.h. So this file defines some macros that we're going to use now to make it a lot easier to implement this function. Typically, we would do something like this: integer total equals 0, and then we're going to have a for loop for integer I equals 0, I is less than count, plus I. Now, during the loop, we're going to total plus equals the arguments for this function, which we still don't know how to do this. And then at the very end, we're going to return the total to the caller. Let's see how we can actually use the macros so that we can obtain each of the arguments that the caller will pass in here. The caller might pass 1 argument, 2, 3, etc. So how do we do that? First thing we want to do is define a variable argument list using the va_list macro. Let's call it VL. So this is our variadic list variable. Next, we want to tell the function that we are going to use the variable list, and we want it to point to the first argument in this list. The way to do that is to use va_start macro, and this takes 2 parameters. The first one is your variable list parameter, and the second one is the first argument that is being passed to this function. In this case, it's the count. So this is how we initialize it. Initialize and use the variable list. Okay. As you may have guessed, because we're using va start, we also need to use va end at some point before we return from this function. Typically, this will be here va end, and this takes in the variable list. This will free up any resources used in the process. So basically, if anything has been defined, allocated by va start, this will clear it up. All right, so lastly, how do we get the argument? There's a third macro that we want to use, va_arg. So this takes 2 arguments, the same variable list that we're working with, and then T stands for type, which is the type of the argument that we want to read off of the argument list here. If we say integer here, it will know that it needs to read 4 bytes of the stack, and that becomes the next argument. This function doesn't do any checking for you. In this approach, we simply trust the caller to pass in the correct number of arguments. Alright, so this is pretty much all we need to implement a variable list of arguments function, also known as variadic function. Next, let's see how we can call this and test it out. So let's say we want to printf sum equals %d, and then we're going to pass in our function. Let's say we have 4 arguments, 1, 2, 3, 4. Okay, so let's assume we want to just sum up the 4 numbers from 1 to 4. This should give us the value of 10. So let's give this a try. On the keyboard, I'm going to hit on Ctrl F5 to compile and run. Click yes. Okay, so as you can see now, the sum equals 10. Alright, so this function is basically working as expected. Let's give this a second try by passing in 2 here instead of 4, just to show you that you can even if you pass it 4 numbers, it all relies on the fact that this is the count that it's going to look at. So in this case, it's just going to add 1 and 2. So Ctrl F5 again on the keyboard to compile and run. Yes. As you can see now, it's summing up only the first 2 arguments, 1 and 2. The result is 3. Periodic functions in C. Technique number 2. Okay, let's jump into Visual Studio. In the previous lecture, we saw how to implement the sum function using a variable number of arguments by passing in the count as one of the parameters. Today, we're going to continue on the same example by showing a different technique. So let's get started. This is how most people would actually implement periodic functions in C and C++ by relying on the count or some argument here that they can use to figure out how many parameters are being passed in. Next, I'm going to show you the second technique, which I personally tend to use, which, as we said, is going to use a magic or sentinel value. Number 2, passing a sentinel or magic value. The main difference here is that instead of passing in a count, I'm going to just rely on one of the values to be a magic value. For example, 0, -1, null in case of pointers, etc. Let's go ahead and copy paste this. Instead of rewriting the whole thing, I'm going to just copy this, Ctrl C on the keyboard, come down here and then Ctrl V to paste it. And I'm just going to call this sum2. And the first change I'm going to make, or maybe the main change that we want to make, is getting rid of this count, just simply by saying ... Well, as you can see now, Visual C doesn't like this. It says that unnamed prototype parameter not allowed when body is present. So this means that it needs at least one argument before the ... So we're forced to kind of do something like this. Integer, let's say number 1. So we'll just pass in the first number as an argument here. Continuing with the changes, this will remain the same. We're going to use the same VA list variable. The main difference first here becomes that this gets initialized with number 1. And as a matter of fact, we can start the total with number 1. Alright, so next let's look at the for loop. We don't have the count anymore, so we have to get rid of this. So what do we do here? We're simply going to do an infinite loop and rely on the argument coming from the argument list. So I'm going to say here integer arg equals, then copy this here. And we're expecting integers to be on the call stack. So this value here is the value we get off of that variable list. Since we're using the sentinel or magic value technique, this is a good time to test if this is a magic value. In this case, because we're summing up numbers, I'm going to use 0 as a magic value. So if we get back 0, then we can simply break from this loop. That means no more arguments. Okay. Otherwise, it's a non-zero, so we can say total plus equals arg. And the nice thing about this is that we can now even sum up positive and negative numbers. The only magic value that I can think of here is 0, because that should tell us that there's no more numbers to be added to the list. Okay, and then lastly, we do the same thing. We have to call VA end to free up any resources, and then we're done. Okay, so let's give this a try. I'm going to copy this code, just put it here and say sum2 equals, and then call sum2 instead of sum1. Now remember, sum2 doesn't need a count, so we're not going to need this. We're going to just do it this way and then put 0 at the end. If we don't put 0 at the end, chances are that we're gonna get into an infinite loop and probably cause ourselves some kind of runtime issues. Maybe this will cause a crash or unexpected behavior in the system. So be aware of this side effect as well. Which can also happen, by the way, if you put something like 10 here when you actually don't have 10 arguments. I personally don't like this approach, because this technique, you always have to count and figure out how many arguments you have and then put that in here, so they can quickly get out of sync. Anyways, this is 4 numbers, so let's put 4 in here again. In this case, it's just a matter of remembering to insert the magic value at the end. Alright, so to compile and run, hit Ctrl F5 on the keyboard, then click yes here. Oh, I'm getting some errors because of this integer. This is not needed here. So let's compile and run again. Ctrl F5. Yes. Alright, so now as you can see, sum for the first technique equals 10. Sum2 for the second technique equals 10. So basically both approaches give us the same value. And the main difference is that the first technique uses a count as a first argument, whereas the second technique does not use the count, but simply relies on some magic value. So this is pretty much it for periodic functions in C++. Mixing C with C++ code. There will be times when you need to use your C code from within a C++ project. However, you may run into some issues when you try to do that, and that's the topic of this lecture. So what is the problem of mixing C with C++ code? When you compile your C code with a C compiler, the code that it generates is not always compatible with a C++ compiler. Remember that we're dealing with two different compilers here. Why are the compilers not 100% compatible? Well, the main reason is that the C++ compilers need to support C++ specific features that are not part of the C language. So they would compile the C++ code differently from C compilers. One of the main differences is around the function names. When the C++ compiler decorates the function names, it will do that completely different from the way the C compiler does it. And this is known as name mangling feature. You can Google the name mangling feature to understand it in more detail, but at a high level, the way the C++ compiler tries to generate the function names as it compiles, it tries to make each function name unique. In doing so, it takes into account the parameter types to generate a unique decorated name for the function. The main reason for that is that C++ compilers support a feature in C++ called function overloading. I'm not going to go into that in details because that's a C++ specific feature that should be covered in a C++ course. However, the goal of this lecture is to understand how you can use your C code from within a C++ project in case you need to do so in the future. Okay, so how do we solve this problem? The first solution is to compile all your C code along with C++ code together using a C++ compiler. However, this may not be always possible. There might be cases where you don't have the source code, or if you try to compile all your C source code with C++ compiler, you might need to make a lot of changes to the code so that the C++ compiler can accept it. So this option may not be always possible for everybody. Okay, the second solution was introduced into the C++ compiler itself by defining a new concept called the extern-C syntax, which you can surround around your C code so that the C++ compiler does not use the C++ specific features on your C code. So basically, if you surround your C code within extern-C sections, then in that case, the C++ compiler can be backward compatible with the C compiler and not try to use the C++ specific features on that code. Also, the C++ compiler defines a macro called __C++, which can be very useful in this situation. Okay, so let's talk more about the extern-C. So basically, what you want to do is you want to surround your C code within extern-C sections like this. You just specify extern quotation mark C quotation mark and then curly braces so that you can put all your C code in here. Notice that extern-C is part of the C++ compiler. If you try to compile this code with your C compiler, you will get some runtime errors because it doesn't understand the extern-C concept. This was only introduced to the C++ compiler. Okay, then how do we make our code compile for both C and C++ compilers? So like I said, compiling this with a C compiler will generate compilation errors because extern-C is only known to C++ compilers but not C compilers. To overcome this problem, you need to use the extern-C only when compiling with C++ compilers. And to do that, you would need to use the preprocessor fdiff so that it helps you surround it only when you're using a C++ compiler. So if you say fdiff C++ around this code, then that means only if it's inside the C++ compiler, we're going to use the extern-C. So basically, this is what most people do. In your C code header file that are supposed to be used by the C++ compiler, you will see the following practice being implemented in all these C header files. So at the beginning, there will be an fdiff C++. If this is a C++ compiler, then we inject the extern C with an open curly brace. Then at the very bottom of that file, you would say if diff C++ again, you need to close that curly brace. And then in between, you will put your C code. So basically, if this was a C++ compiler, you will see extern C, open curly brace, and then your C code in here, and then closing curly brace at the end. However, if this was a C compiler, this will not do anything, so you end up with just a typical C header file. The takeaway from this, if you want to expose your C code to C++ projects and C++ compiler, you need to use this technique moving forward. In the next lecture, we will modify our library that we built in the static library section to make it compatible with C++ project by using the extern C. So see you in the next lecture. Okay, here I am on Visual Studio. Let's go to File and then Recent Projects and Solutions so that we can open up our previous solution, which is called My Library Solution. In my case, it's the first one here, so I'm going to click on that. So this will open up the library solution we had created together in previous lectures. Remember that this solution has two projects right now. It has My Library and then a reverse demo 3, which is a C console app that uses the library. The active project or startup project is the reverse demo 3. Clearly the name is bold and highlighted more than the other one. Okay, if I expand my library just to look at the source code again, we have one function in here. Our function prototype is defined inside mylibrary.h. So let's see how we can use this from the C++ compiler. In order to do that, I'm going to create a new project that's a C++ project. So this is the first time we create a C++ project, and the reason is we want to understand how to use the extern C concept. So let's right click on the solution and let's add a new project. Add new project. So from the add new project window, make sure you select Visual C++ 132. And also make sure you have console application selected. And let's call this CPP reverse demo. CPP stands for C++. Click OK. Since this is a C++ console application, we can click Finish and let Visual Studio create a default CPP file for us. Okay, so as you can see here, now my solution has three projects: CPP reverse demo, My Library, and reverse demo 3. So currently, the CPP reverse demo is not the active project. So let's go ahead and make that the active project. Right click and then set as startup project. Now this is the active project. We can expand and take a look at this. Double click the CPP reverse demo.cpp. As you can see, this is what Visual Studio has created, a main function in a CPP file. So our goal here is to see how we can use the library from within this CPP project. So the first thing we want to do is include mylibrary.h. As you recall from previous lectures, if we try to open this document, we won't be able to open it because right now this project doesn't know where mylibrary.h exists. So we need to tell it where to look for this file. So let's go ahead and right click on the CPP reverse demo project and then select properties. And from the Visual C++ directories, we're going to add the include directory path to our library. So click the arrow down and then click edit. And we're going to use the solution dir macro here. I'm going to use this because this shows me where my solution goes. And inside this, there's a My Library that has the header file. So simply come here and then click on this, copy solution dir, followed by My Library. That's where my library folder is a subfolder underneath this path. One folder down, My Library, is where I have the include file. So simply click OK and then click OK again here. So now if we try to open this, right click, open document. Now we can open the document, as you can see. Okay, let's go back to the CPP file and write our code here. Our str equals hello from C to C++. Now I want to say printf reverse equals %s, and then we're going to call reverse string function, give it the str here. Okay, let me try to compile this. Ctrl+Shift+B on the keyboard and see what happens. Okay, we're getting an error here. Let's take a look at this error and let's look closely. As you can see here, it says unresolved external symbol, char pointer C declaration, reverse string char pointer. And as you can see, the name here is being mangled. It says quotation mark reverse string double @ YAPADPAD@Z. So this is what the C++ compiler is doing to the function. It's actually expecting the function name after it decorates the name to be like that in the lib file. Let's go ahead and link with the library. Since we have the library built, we can simply add it to our references here. So I'm going to say add reference and select my library. So now this will link with the library. As you can see, this project now depends on the library. So if we compile again, Ctrl+Shift+B, we still get the same error here in the output window. You can see we're still getting the same error even though we are linking with the library. And that's because the library was built as a C library. As you can see, this name here is not going to be found in our C library. So what we want to do here, we want to tell the C++ compiler to stop decorating this reverse string function name. It shouldn't do C++ compilation on the header. So open the document here, and simply what we want to do is we want to say extern C for this function. Let me save this and let's rebuild the whole solution. Remember, our solution has a C console app that uses the library. It also has a CPP project that uses the library. So if we do it this way, we're going to make the CPP project happy. However, we're going to make the C console app unhappy. It's going to complain about this. So let's see that in action. Let's rebuild the whole solution again. Okay, so I'm getting some errors here. My library.c was compiled just fine. And then it started rebuilding the second one, which is after the library. Number 2 is reverse demo 3. As it compiled main.c, it got into a situation where it's not happy with that. Double click on that. As you can see, it's not happy with this. So this is not going to be okay with the C compiler. This is only a C++ compiler. As I mentioned in the slides, what we want to do here is we want to say ifdef __C++. Then we want to do extern C. And we're going to do it for the whole file. So we'll just open a curly brace here, then end if. Okay. And now I'm going to copy the same thing at the end and just simply close the curly brace. Now that we do that, we don't need this anymore. This is not needed. So now we can save it like this. So this is how typically we do it. We say at the beginning of every C header file, if this is a C++ compiler, I'm going to make everything in here extern C. At the very end, you need to close that curly brace, and that's why we need to repeat this. Again, if it's a C++, then we remember we open the curly brace. Let's go ahead and close it. All right, with this change, we should be able to compile all 3 projects. Let's rebuild solution again. All 3 succeeded, 0 failed, 0 skipped. So awesome. So now we have a C project that uses our library and a CPP project that uses our library. And since our CPP project is the active one, let me go back to the main. Since this is the active project, if I hit Ctrl F5 on the keyboard, I'm going to run the C++ project. And now as you can see, reverse has reversed hello from C to C++. So this is pretty much how you mix C and C++ code. Basically, all we have to do is in our C header files to always use this technique and make everything as an extern C, only if it's a C++ compiler. And with this, we conclude this lecture.